Hey, Jack.
Yeah,
Where are we?
in my bedroom.
Yeah, why are we in your bedroom?
That's because I'm baking my toys.
That's right. So, when I first unveiled the 3D printer, there was a few people who were kind of curious how it worked, and I thought the best way to illustrate that would be to present a use case scenario. Now, this is Jack's bed. It is your typical flat pack garbage that we got for cheap on Amazon. And when I put it together, these doors had the option of a couple of different handles. One was blue and one was red. Jack, what's your favorite color?
Red.
So we used the red handles. What happened to your handles?
We snapped off of these doors.
Yeah, because they were the cheapest Chinesium grade pieces of garbage ever. Because Jack had red handles, I don't want to have to replace these with some other store-bought handles because I'm probably not going to find red handles in the store. So I have red filament. What color is this?
Red.
What's your favorite color? Good. This allows me to print out whatever I want in this color. So all I got to do is measure 3 3/4 inch handles. I know how big these need to be. I have a general idea what I want them to look like, and because I have a 3D printer, I can make whatever the heck I want.
Daddy made this out of black and filament.
I did?
Yeah.
Wasn't that really nice of me? Well, welcome to my office. It may look like a recliner with my laptop on my lap, but this is a very serious place of business. We get a lot of stuff done right here, right? So before we can start, we first have to have a model. So basically it's a block, and then you can remove or add pieces and ultimately end up with a shape. And the shape is a chunky handle, and the holes are in just the right spot, so I can screw through the back of the drawer into the handle. And saved. So now that I have the
Great.
file exported, we have to take it downstairs and we have to prepare it for printing. Welcome to my project station. This is my workspace under the stairs to the basement. I have a workstation PC set up running the slicing software that I use to prepare my models and then run the printer. Now, to understand what all that means, we first kind of have to understand how these printers work. This is a glue gun, and if you don't know how a glue gun works, it's pretty simple. There's a hot end that will melt the glue. The glue stick goes in the back of the glue gun, and there's a mechanism in here to feed it into the hot end. What happens down here is it melts and it comes out as an extruded bead of glue. Printer works the exact same way. The difference is, instead of glue, we have a roll of filament. The filament is 1.75 millimeters thick. It gets extruded into the hot end, which squeezes out through a tiny little 0.4 millimeter hole. The side effect is you're laying down these tiny little beads of plastic, and they have to be built up in layers. What I'm doing here is I'm taking a model that was exported out of Fusion 360, and I'm going to slice it so that the printer can lay down beads of plastic one layer or slice at a time. What the printer needs is something called G-code. The physical model is a chunky thing. It has to be converted to the G-code path. That's where the slicing comes into effect. So I drop it here into the build plate, which mimics my printer, and then this does some technical widgetry, and it exports a G-code file that I then load to the printer. I open the file, drop it on the plate. Unfortunately, it didn't save the proper dimensions. I don't know what's up. Fusion 360, and my x-axis needs to be 127 millimeters. Ta-da! Now it's fixed. 127 millimeters. Now I'm gonna rotate it.
Daddy,
on
where's the
side.
other one? I remember the other one.
They're both there. Okay, so now I've got my
Here,
two
handle.
handles on my build plate. Save to file and save. And that's it. So here's my printer in all its glory. This is a cheapo Chinese knockoff of the Prusa i3. The way these things work is this bed is heated to help the plastic stick and not warp. And this takes a ton of power to keep this thing hot. This runs at about 60 degrees Celsius. The hot end here, so this is the extruder mechanism. The filament goes in through here and gets extruded through the hot end. This runs at about 200 degrees Celsius. So when this thing is running, it's drawing about 15 amps, which was the full load potential of the power supply. Some people complain about it frying the power supply. A few people actually caught on fire, so I didn't want to mess with that. So I replaced the power supply with a 30 amp supply, so there's plenty. MOSFET driver boards here to take the power that powers the plate in the hot end off the main controller board, because these things will get hot and fry, and that's an expensive fix. So preemptively I moved that stuff to these MOSFET driver boards. So now most of the 15 amps comes through here, and these are designed to handle it, where this is not. First things first, we got to heat up the bed for PLA, which is the type of filament that I'm using. Printer's preheated. We have the hot end is set at 190 degrees Celsius, and it's there. The heated bed's at 60 degrees Celsius, and it's also prepped. So now that everything's hot, there's one final step that's important. The glass plate by itself will not allow the PLA to stick, so I need to give it a little assistance with this Elmer's glue stick. So rub it on here, give it a good layer, and that will give it something to stick to. This is not strictly necessary, but I have a Raspberry Pi that's loaded up with software called Octopi, and it's connected to the printer through the USB cable here, and I have this webcam, and what this allows me to do is remotely control the printer and see a live stream. So I'm running Octopi here in the web browser. The Raspberry Pi acts as a server. It connects to the printer, it sends commands to the printer, and it pulls in the webcam and shows it on this website. The cool thing is I can see this website from anywhere because I can VPN into my house. I actually have it set up on my phone so that I can VPN into the house, pull this web page up, and see how the printer's doing. Normally you load this thing on an SD card. I can do it straight through this interface, which is this simple. So I go to upload, then I find my file, and it loads it into my list of prints. If I switch over here to the webcam view, you can see that it's a live stream. I also have some controls here, so I can home the printer by hitting this button, and it homes the head. I need to load and print, and it takes off. And now we just gotta wait 2.5 hours for it to do its thing.
Yeah, you're making it out of wood.
You excited?
Yeah! I'm receiving red handles. Mommy, time to make a better printer.
Out of the mouth of babes, right? I mean, here's your butt. I had to run down the street to get some gas for my lawnmower because today is also tune up my lawn equipment day. But I want to continue to monitor my 3D print. What's a guy to do? Well, with the power of the internet and the VPN connection to my house, I can see it on my phone.
I'm so excited.
Are you?
Yeah.
All right, let's see here. We got 99%. Oh, whoop, whoop, up, up. She done. Slide this guy out here.
Are we done?
Pry this guy off.
Hey!
We gotta clean the glue off, but check that out.
Yay! We're fixed!
And the glue just washes off with soap and water. Hey Jack, how do you like your new handles?
Yeah!
Pretty cool, huh? Mm-hmm. And they're just the right color. And it basically didn't cost me anything. So, yay!
Yay!